All right, everyone. Welcome to Math 1530. This is the completion of section 2.1. We completed in class up to number 10, and we're starting here at number 11. The problem says use the box and whisker plot to determine if the shape of the distribution represented is symmetric, skewed left, skewed right, or none of these. So that first brings in a new representation for us, which is the box and whisker plot. So I'm going to highlight that. And so let's look at this figure here and talk about why it is a box and whisker. So clearly you can see the box here. That's this rectangle. That's the box. The whiskers would be the extensions outside of the box. We call those the whiskers. Okay? So this is a whisker, and this is a whisker. So in the box and whisker, we get different pieces of information. So it is the display of a distribution. In it, we have on these whiskers, we have the lower end based off of how the number line progresses. As you can see over here, this will be the lower end and this will be the upper end. Notice how the data seems to be slim here on the left side because of how the box is further to the right. So if we use our visuals from number 1 for the 4 types of distribution, that would look like a tail being here on the left. And we know that if there's a tail on the left, that means that my data is skewed left. So let's also put another indicator, a couple of other indicators here, so that we know when I look at a box and whisker, when it is skewed right or skewed left. So since the whisker is shorter on the upper end, I'm going to write that. So when the whisker is shorter on the upper end, and that will be here, this being the upper end. It's only called the upper end because the numbers are greater on this side, upper end. Then the data is skewed left. Conversely, when the whisker is shorter on the lower end, where this would be the lower end, then the data is skewed right. Okay. Alright, so we have our box and whisker. These areas here are the whisker. Here is the box. Let me add here also that in here the median is given in that data. So it's shown here by this line. We're going to talk later about the quartiles, quartile 1 and quartile 3, and we're going to see that living inside of a box and whisker in another problem. Let's continue on to number 12. In number 12 it says use the accompanying data set to complete the following actions, and we want to find the quartiles, the interquartile range, and identify any outliers. So let's first start by defining quartiles. Let's define what a quartile is and what that means. So when we find the mean, mode, and median, we automatically find one of the quartiles. We find quartile 2, which is also the median. And so quartiles means that the data is cut into fourths. So there are 3 quartiles. There's quartile 1, which is the first fourth, quartile 2, which is the half, and quartile 3, which is the third fourth, and then the data has another fourth part. But quartiles, there are 3 quartiles that we can, in other words, divide the data into 4 parts, giving us 3 quartiles. But in order to do that, I need to put the data in order. So this can be found in our calculator, but I do want to demonstrate how do we find that if I don't have a calculator. So the first thing I'm going to do is put the data in order. Remember, the calculator will put it in order for us, but I'm going to put it in order to talk about the 4 divisions of the data. So as I look through my data, I see that the smallest value, let's just make sure I scan that really good, is 54. 54. The next number would be 55. Look for 56. 57, that's 1. 57, that's it again. 57. Okay. 58. 58. Okay. 59. I don't have a 59, but I do have a 60. 60 again. Then there is 63, 64, 64, then 79. I'm going to count and make sure. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have all of my data. So quartiles. So this data has 15 numbers in the set. Well, if I divide 15 by 4, that is 3.75. So I know that my data can be split or divided into 4 parts that have at least 3 numbers in it. So if I kind of think about it like this, 1, 2, 3 is the first quartile. 1, 2, 3 is a division. There's another quartile. 1, 2, 3. 1, 2, 3. And then one set only has 2 numbers in it. So the quartiles are the numbers being divided, the set of numbers being divided into 4 sections. So it's the easiest thing to do once you're finding quartiles is to find your median, because it's the one that you know from mean, mode, and median. It's the middle of the data set when the data is in order. Well, there are 15 numbers, right? So that means that there should be 7 numbers on the left of the median, 7 numbers on the right, because the middle innermost number would be the median. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that means right here is our median. That's the median. But the median is also called quartile 2. So I have found my second quartile. The median is also known as quartile 2. So the median is 58. Okay? Now to find quartile 1, I need to find the median of this half of the data. Well, there are 1, 2, 3, 4, 5, 6, 7. If I go here, 1, 2, 3, 4, 5, 6, 7, 8. That's the set of the data that I'm going to use to find my quartile 1. The quartile is simply the median of that part of the data. The median of that part of the data. So right here are the innermost numbers there, 57 and 57. If I add them up and divide that by 2, I'm going to get 57 again. So quartile 1 is also 57. So quartile, remember quartile 2, that's what I started finding. First I found quartile 2 is the median. Then to find quartile 1, find the median of the first half of the data. So here I did that. Here's my first half. So I'm at 1, 2, 3, 4, 5, 6, 7, 8. Well, 8 is an even number. That means that the middle is right here. The average of 57 plus 57 is 57. To find quartile 3, I'm going to do the same process I did. So to find quartile 3, I'm going to find the median of the second half of the data. Well, let's look at that. The second half is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. 1, 2, 3, 4. So these two numbers are the middle, innermost numbers of that of the second half of the data, right? Now, one thing I have to consider is when I found the quartile 1, I used 1, 2, 3, 4, 5, 6, 7, 8. I used the median. So when I consider the next part of the data, I'm not going to use the median. So I am only considering 1, 2, 3, 4, 5, 6, 7 data points. Well, if I have 7 data points, that means that there is a center number, because I would have 3 entries on the left, 3 entries on the right. Where would my data, the middle of that data, land? It would land right here. Let me say that again. When I find quartile 1, I include the median in that first half. But when I find quartile 3, I do not include the median. So my quartile 3 is found by looking at these 1, 2, 3, 4, 5, 6, 7 numbers, where 63 is in the middle. So quartile 3 is 63. Okay? Alright, now to find the interquartile range, then I need to, we know what range is. We take the middle, we take the maximum value, and we subtract the minimum value from it. So to find the interquartile range, I'm going to subtract Q3 minus Q1. Well, that means my interquartile range is 63 minus 57, which is 6. Okay? Alright. Now, Now, the next one says identify any outliers. Well, outliers are determined by numbers that are far from or differ greatly from the majority of the data. The majority of the data is in the 50s, the late mid 50 numbers, and then up to the mid or low 60s. Y'all see that? Low 50s up to 60, and then to the low 60s. 79 is not really a part of that general set of numbers. Had that been like 69, maybe so, but this seems far. So we would call this an outlier because it lies outside of the data set. So identify any outliers. There exists at least one outlier in the data set, and it is 79. And why? Because 79 lies outside of the data set. So there does exist an outlier. All right, number 13. So here I'm going to use my calculator to determine my quartiles. So I'm going to show you this one, number 12. I was able to show you manually what to do. For number 13, I'm going to use my calculator. It says the data shows the number of vacation days used by a sample of 20 employees in a recent year. Use technology to answer parts A through B. First, find the data set's first, second, and third quartiles. And here's our data. So I'm going to move my paper away for a moment, and I'm going to use my calculator to find my quartiles. We talked about in class how to use our stat button, so I'm going to go to stat. I want to enter some information in a list, so I'm going to press enter. I see that I have information in my list already, so I'm going to go and clear that out. And let me enter into my list. Remember that